In this film, we will show you the installation, calibration and parameter setting of AquaDMS. First, connect the inlet. Then connect the outlet. For the electrical installation, unscrew the screws and then remove the instrument from the housing. The connection diagram can be found on the back of the instrument. It shows the terminals for power supply, alarm relays, 2 mA outputs and 2 digital inputs, as well as the terminals for the sensors. Pull the cables through the cable glands on the bottom of the instrument. Make sure that power is switched off during the wiring. Connect cables and terminals according to the connection diagram. Take out the terminals for cable connection. Connect the power supply to the green terminals marked L and N. Then we connect the alarm to terminals 76 and 77. AquaDMS is equipped with 2 analog outputs. In this video, we connect the outputs for reading out the measured value and temperature. Observe the polarities of the milliampere outputs, which are indicated by +- signs above the terminals. The digital input for flow control is already connected. After that, replug the terminals and once again check the correct allocation of the cables. Put the instrument in the housing and screw it tight. When the power is switched on, the instrument starts with a self-check and displays first the time and then the measured values. All output options of the instrument can be set manually in the test menu. You can switch each relay and set values for each milliampere output to check whether the wiring is correct and the output reaches the PLC. As soon as you exit the test menu, all test settings get lost and the outputs return to their previous states. No valid access code has been set at delivery. Use access code 1612 to access all parameters and settings. The sensor is delivered in a transport protection with highly concentrated saline solution. Remove the transport protection from the sensor and install it. Before you connect the cable to the sensor, check that the correct measuring parameters are set in the menu. Now connect cables and sensors. If a temperature sensor is connected, set the temperature mode to Auto to get the reading. If the measured value deviates from the expected value, you can correct the value in the menu. If you didn't connect a temperature sensor, you can set the temperature value manually. If you want to use temperature also for compensation, you can set a temperature coefficient in % per degree Kelvin in the temperature menu. A coefficient of 2% per degree Kelvin has proven useful for many applications. You can also set the reference temperature for compensation. Make sure that all cocks are in their correct positions, especially that the sample cock is closed and the sensor screwed in tight. Open the water inlet. The event message, "No water," disappears. You can calibrate the disinfectant measurement as soon as the measurement has stabilized. For the calibration procedure, you have to determine the chlorine concentration in the water with a reference method. Carry out a reference measurement using, for example, our photometer radon. Take a water sample at the sample point and determine the chlorine content. Use the reference value for calibration. We measured 0.64 milligrams per liter. On the basis of this value, the instrument then calculates the sensor-specific data. In this case, the slope is 22.5 mV. The info menu displays the last 10 calibrations. The instrument has various alarm functions. In the Alarm Action menu, you assign the alarm relay to the events. We connected 1 mA output that may be used as readout for measured value, temperature value, or control variable. You can choose whether you want to set the output range to 0 to 20 or 4 to 20 mA, and whether you want a 22 mA alarm to go off in case of faulty measurement information. The milliampere output can be scaled if you're interested in just a certain section of the measuring range, for example 0 to 1 milligram per liter. The minimum value always corresponds to the minimum milliampere value, in this case 0 milliampere. The maximum value corresponds to 20 milliampere. Krypton systems are equipped with our patented automatic sensor cleaning, which cleans the sensor electrodes in regular intervals. Before activating the cleaning function, make sure you set the correct time and date. Check time and date to make sure the starting date is not in the past. Then select the cleaning intervals. You can choose between 0 and 7 times per week. For most applications, 1 cleaning cycle per week has proven absolutely sufficient. We recommend carrying out cleaning during night hours or at times when relatively low fluctuation can be expected. During the cleaning procedure, the milliampere outputs are frozen You can save all settings on the SD card. To restore them after a reset, or to transfer the settings to other instruments. It is also possible to load new software into the instrument via the SD card. After uploading a new software, the system first performs a self-test and then displays the measured values. All former settings are saved. The SD card function can be used as data logger. You can select the parameters to be logged. The logging interval can be selected freely. If the memory card is full, logging will either be stopped or older data overwritten depending on your specific settings. Storage space is indicated by an analog bar. To remove the SD card, first switch off the logger and take the instrument out of the housing. The SD card is in the rear in the upper right-hand corner. Push to eject.